Section 4.1, number 13. Construct a polynomial function that might have the given graph. All right, so we have a polynomial function here with a few x-intercepts and a y-intercept. So let's figure out what these ordered pairs are. We have x-intercepts at -2, 0, -1, 0, and 1, 0. Now, while I'm at it, I'm going to make a note of the fact that at -2, 0, the graph crosses the x-axis, which implies when I find its factor, it will have an odd multiplicity. The second one at -1 comes down, touches the x-axis, and then goes back up in the other direction. So I know that when I look at the factor that goes with the 0 of -1, it has to have an even multiplicity, or an even power on it. And the last one at 1 goes through, goes from the top, touches, crosses, and goes through. So the last one crosses, again implying that one has an odd multiplicity. I don't know why I said it that way. Okay, so the zeros, and then the factors. Oh, you can't see that. There you go. We got -2. That'll give us a factor of x plus 2. We have -1, which will give us a factor of x plus 1. And we have 1, which will give us a factor of x minus 1. Looking at this graph real quick, 1, 2, 3 turning points. 3 turning points implies a degree 4, which if you put together x plus 2 with an odd multiplicity, we'll make it 1. X plus 1 with an even multiplicity, we'll make it 2. And x minus 1 with an odd multiplicity, we'll make it 1. 1 plus 2 plus 1 is equal to 4. So this will give me a degree 4 polynomial. And I left myself a little space here because I'm not sure what my leading coefficient will be. I will figure that out from another point on the graph. This graph passes through the y-axis at 0, 1. You can use any of the other points. I'm just going to use this one because I know my x-intercepts already gave me my zeros. So if x equals 0, then the polynomial with 0 as input will produce the number 1 as output. All right, so let me multiply this stuff out. Oh, you know what? Boop, 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 boop. This one needs to show up twice. So let's write that. So now we'll multiply all this stuff out. This is going to take a little while. You might want to fast forward through this. Ha ha ha. All right, that's that one. I'm going to do this one too. X plus 1 times x minus 1, that's a difference of 2 squares, so it's x squared minus 1. Clean this up a little bit. Combine like terms. We got x squared plus 3x plus 2 to x squared minus 1. Multiply all that business out. X to the 4th, there's your x to the 4th, minus x squared. That'll be a 3x cubed and a minus 3x. And then these two, 2x squared and minus 2. See if we can clean up a little bit. We got an x to the 4th. We have a 3x cubed. We got some x squared stuff happening here and here. Term with an x and minus 2. All right, so now I'm ready to plug and chug my 0 and set the function equal to 1 for the output. Brackets, plugging in 0 for the value of x. so 0, 0, 0, 0. That's nice. So 1 equals a times negative 2, or negative 2a, right? Equals 1. Divide both sides by negative 2. And I get that my leading coefficient should be a negative 1/2. So P of x equals negative 1/2. I'm going to put it in standard form as well as factored form. So x plus 2, x plus 1 squared, and x minus 1. That's the factored form. And the standard form all multiplied out. So negative 1/2 x to the 4th plus, well, multiplying by negative 1/2, so this will become minus 3/2 x cubed minus 1/2 x squared plus 3/2 x plus 2 divided by 2 is 1. There you go.